In this video, we'll discuss that how the overall gain or voltage gain or current gain is affected by positive feedback and negative feedback or feedback system. This is a block diagram of a feedback amplifier. This is the gain of the amplifier. Suppose A, the source voltage suppose Vs, the input voltage Vi, the output voltage Vo, and the output voltage if given to the input of the feedback circuit, and the output of the feedback is Vf, and the feedback fraction that is equal to beta. First to consider the negative feedback amplifier. For negative feedback amplifier, the input voltage is equal to the source voltage minus the feedback voltage. The feedback voltage coming from the feedback circuit is equal to Vf. So the input voltage given to the amplifier is equal to source voltage minus the feedback voltage. And how the gain of the amplifier, you calculate the gain of the amplifier. Gain is always equal to the output voltage divided by input voltage. So for the amplifier without feedback, gain is equal to output voltage divided by input voltage. So the output voltage will be equal to the gain times the input voltage. Similarly, what will be the amplification for the feedback circuit? That is, beta will be equal to output voltage by input voltage. The output voltage here is equal to Vf, voltage after feedback, and the input voltage is equal to Vo, that is the output voltage which is coming from this amplifier. So what will be the feedback voltage? Feedback voltage will be equal to beta into the output voltage. So if you substitute the value of Vf, that is the feedback voltage, from this equation 3 in equation 1, then the input voltage, this one, the input voltage Vi will be equal to the source voltage minus beta into V0. So if you substitute the value of V0 output voltage from equation 2, that is equal to Vi into A, then this will be equal to how much? Vs minus A beta into Vi. So Vs, that is the source voltage, will be equal to Vi. If you take A beta Vi to this side and write in RHS side, then you take Vi common. So in the bracket you have 1 plus A beta. So this is a equation, well-known equation for negative feedback amplifier. And for positive feedback amplifier, what you do? You take the input voltage is equal to source voltage plus the feedback voltage. Okay. For positive feedback, you add the feedback voltage with the source voltage. So the input voltage will be equal to the source voltage plus the feedback voltage. And if you work out in the similar manner, then you will get for positive feedback Vs will be equal to Vi into 1 minus A beta. For negative feedback you will get Vs is equal to Vi into 1 plus A beta, but for positive feedback you will get Vs will be equal to Vi into 1 minus A beta. Then you do simple mathematics, you divide the left hand side and right hand side by V output, because you have to find out the gain after feedback and the gain before feedback. You have to derive that equation. So you divide V output in the denominator in the left hand side and also in the right hand side. So Vs divided by Vo will be equal to Vi divided by Vo into 1 plus A beta, and if you take V output by V, you take the inverse, then V output by V S, that is the source voltage, this will be equal to V output divided by Vi, and this will be equal to 1 divided by 1 plus A beta. Okay, and V output divided by the source voltage, this will be equal to the gain after feedback, and V output divided by the input voltage, this is the gain before feedback and this is the gain after feedback. So gain after feedback will be equal to gain before feedback divided by 1 plus A beta. Okay, and if you this is for the negative feedback amplifier, and if you do the same if you do the same mathematics, a simple mathematics for the positive feedback, then you will get for the positive feedback AF, that will be equal to A divided by 1 minus A beta. For negative feedback, AF is equal to A divided by 1 plus A beta, and for negative feedback, AF is equal to A divided by 1 minus A beta. So you can compare how the gain is affected by the negative feedback and in case of the positive feedback. Since 1 plus A beta, this is greater than 1. So if this will be greater than 1, then AF will be equal to A divided by a quantity which is greater than 1. That means AF will be less than A. So the negative feedback reduces the gain of the amplifier. Okay. But what will happen in case of positive feedback? You see, in case of positive feedback, your 1 you see 1 minus A beta, this term is less than A. This term in the denominator is less than less than 1. So if this will be less than 1, then AF will be greater than A, because it is a fraction, so that will go to the numerator. So AF will be greater than A. So in case of positive feedback, what happens? The increases the gain of the amplifier. Okay, when you take the positive feedback, the gain of the amplifier increases, but if you in case of negative feedback, the gain of the amplifier is reduced. So question will come in the examination, how the overall gain or how the voltage gain or how the current gain is affected by positive feedback or negative feedback. A long question will be asked to you like derive an expression for the voltage gain of a positive voltage series feedback amplifier. This is a positive, I have discussed in the previous video about the circuit of voltage series, positive voltage series or negative voltage series feedback amplifier. That is, the input will be this input will be in parallel and output will be in series. You watch my previous video, and you will also ask questions like which feedback increases the overall gain of an amplifier, which one, positive or negative. I have explained positive feedback increases the overall gain of an amplifier. You may ask question overall gain or voltage gain or current gain. Same thing. When you it will be asked overall gain, you also answer for it is either voltage gain or current gain. Similarly, question will come like which feedback decreases the overall gain or voltage gain or current gain of an amplifier. I have discussed that negative feedback reduces or decreases the overall gain of the amplifier. Or sometimes you will be also asked to fill up the blank like negative feedback dash the overall gain of the amplifier. What happens? Negative feedback reduces the overall gain of the amplifier. So you work out some problems, and the problems basically comes from the relation between the gain after feedback and the gain before feedback. That is, AF is equal to either A divided by 1 plus A beta, which is for negative feedback, and AF is equal to A divided by 1 minus A beta for positive feedback. And in the next video, we will discuss some questions for the gain stability. We will discuss the theory of gain stability, and also will discuss some more questions on gain stability. Thank you.